So now we're going to hit up ChatGPT and have it take a swing at describing this for us. That's not where I wanted to go. I'm going to go to File, and I'm going to go to Download, and I can do JPEG or PNG or plain text. And yeah, I'm going to go this time with JPEG. Just check it out. And so I come over here to my downloads, and in downloads, I downloaded this one as JPEG. Previously, I downloaded as PNG. PNG was like 12 kilobytes, no, 11 kilobytes bigger than JPEG. So JPEG was a smaller file size. I'm not sure if it's always that way, but interesting to look at. And I'm going to grab this file here, and I'm going to drag it to ChatGPT and drop it there. And again, if you want the best results, you should be paying for ChatGPT $20 a month. They should be giving me a commission of 10% for everybody I send them, because then I could take my wife to dinner, my wife and kids to dinner. That'd be a fair amount of money, man. I'm sending a lot of people to ChatGPT. Everybody I talk to, I'm like, just use ChatGPT. So here I'm going to say, can you please explain this concept to me in statistics of, and I'm giving it like more than I probably need to give it here, discrete probability distributions, and how are they discrete probability distributions, and how are they related to random variables. Okay, Haas, I don't know where Haas comes from. That's like a Stephen King word from some book I read in Stephen King back when I was young. It's like a phrase like boss. Okay, boss. Okay, Haas. I don't know where that comes from. Understanding discrete probability distributions. A discrete probability distribution is a statistical tool that describes how the probabilities are distributed over the values of a discrete random variable. So how are the probabilities distributed over the different values of a variable that a variable could take on? In other words, it tells us the likelihood of each possible outcome for a random variable that can only take on distinct separate values like integers. Connection to random variables. A random variable in statistics is a variable that takes on different numerical values determined by the outcome of a random phenomenon. When this random variable, like rolling a dice or flipping a coin, when this random variable is discrete, meaning it's a whole number, it's not continuous, it means it can take on a specific set of distinct values, e.g. the number of heads in 3 coin tosses. A discrete probability distribution provides a way to map these distinct values to the respective probabilities. So we map these distinct values that the variable can be to their probabilities. The mapping shows how likely each outcome is when the experiment is repeated many times. So if we're looking at how likely it is when the experiment is repeated many times, that's going to be empirical or relative frequency data, which is somewhere here. Here we go. It's empirical or relatively frequency data if we're repeating it many times. And random variable x, the possible values the random variable can take. And example, if x is the number of heads when flipping a coin twice, x can be 0, 1, or 2. So we flip a coin twice, and we could get heads none of those in neither of those flips. We could get heads in one of the 2 flips, and we could get heads in 2 of the 2 flips. The probability, p of x, and here we're using p of x instead of f of x. That's kind of cool, just to see how ChatGPT talks about it. It gives us a little bit of exposure and makes us a little bit less attached to this fx notation, though fx definitely represents functions. You could also mix it up a little bit and figure it out. So here we have, where did we go? Where's p of x? The probability p of x, the probability associated with each value of the random variable x. So example, if x represents the number of heads in 2 coin flips, then p x equals 0 might be 0.25, p x equals 1 might be 0.5, and p x equals 2 might be 0.25. And then notice that all those add up to 1. And, if we're 50-50 on getting 0.5 times 0.5, right, would be 0.25. And so that would be, the probability of getting 0 in 2 flips. It might be interesting to have ChatGPT explain that to us. And then the probability of getting 1 out of 2 would be 0.5. And so I'm not quite sure how they came up with that number, but it kind of intuitively makes sense. You get a positive. You get a head, and then you get a tail, and the odds of that each time is 0.5. So that kind of makes sense that you get one time and the other time. And then to get 2 heads, again 0.25. We'll copy that and ask it about that. How to represent a discrete probability distribution. A discrete probability distribution can be represented in several ways. Table lists each possible value of the random variable along with its probability. And so example, here's x. So the different amounts that we might get, number of heads we might get, and then the probability of it over here. That's tabular. You could also represent it in a graph. And bar graph where x-axis represents the values of the random variable and the y-axis represents the probabilities. And you could also represent it with a formula. You can express the probability distribution, especially if there's a simple rule governing the distribution, e.g. binomial or Poisson distributions. And so again, the binomial or Poisson distributions will be some formulas that can express probabilities for different outcomes assigned to a variable, in certain situations. So example, rolling a die. If you roll a fair six-sided die, the random variable x can take on any of these values. Since the die is fair, each value has an equal probability of occurring. So here we are doing the classical method of determining probability, where all are equal, and this is also referred to as the uniform. And here we have the discrete uniform probability distribution, right? And that's just going to be 1 over n. And so px1 is equal to 1 over 6, px2 equals 1 over 6, so on and so forth. And we have discrete random variable, a variable that takes on a finite or countably infinite set of values. And discrete probability distribution describes how the probabilities are distributed across the values of the discrete random variable. This concept is central to understanding how likely different outcomes are in any random process that can be described by a discrete random variable. So again, right? I mean, you kind of have to get into it and see if you could sort of make sense of it and understand it. And we're going to explore this a little bit further. And to do that, I guess we'll break it up. We'll do it in the next video. See you in the next video where we'll explore it further.